Welcome everyone. So this is Soil Test Series webinar number 4, and so this will be the last webinar of the series. Thanks everybody, and it's being held for the Hughenden Richmond Producer Performance Group and the Redcliffe Innovation Hub Group. So once again we've got David Hardwick from Soil, Land and Food, and tonight we're going to be talking about individual soil test results and everyone working on their soil action plans. So once again, these webinars are supported by Southern Gulf NRM through funding from the Federal Government's National Landcare Program under the 2 projects, Profitable Producers Creating Healthy Landscapes project and also the Ebeef Smart Farm project. Just while we're here, upcoming events, we're looking at doing some climate workshops. The main focus at the moment is Cloncurry, Julia Creek, but if people are interested in doing Hughenden and or Richmond, let me know. I'm just negotiating these through Megan Munchenberg at the moment. So just let me know if there is a huge demand. And look, they've already done a workshop over at Hughenden last year, but if there's demand, we could go again. We've got an Ebeef drone webinar coming up. It'll be held before the upcoming drone field day to give everyone a bit of a taster before we do the actual field day. And the field days we're hoping to be held that week of 26th of October. And the dates we're looking at, it'll be one day over there, like that Hughenden Richmond area, and another day over, over this way, say McKinley with the, the smart farm here. So I'll keep you posted on all of that. And basically that's my little overview, and I'll now stop sharing and hand over to David. So welcome once again, David. Really appreciate your time and appreciate everybody giving up their Friday evening. Thank you.
No worries. Thanks, Anne. Thanks. Yeah, thanks everyone for coming back. It's been a few weeks. Just getting my screen shared and sorted out. Yeah, so tonight, as Anne said, is a bit of a wrap-up day, pulling it together for you guys, because we kind of covered a fair bit of theory through the first couple of webinars. And you guys have a soil action plan, which I'll just bring up. And I'm just going to tonight, so if you're driving along, like Roger's driving along, but hopefully the other guys, you've got a copy of this handy, because you can just sort of fill it in, and even if you don't complete it all tonight, it's kind of a guide for you. So we're just going to go through step by step the steps in the action plan. Like, we're just going to one by one look at the tests and look at your soil type, and which most people know already, and then just try and assess some of the important aspects of soil health. And not all of these things are going to be relevant, but a few of them are, obviously, like organic matter, and then have a look at phosphorus and sulfur, maybe just to see whether we think they're limiting, especially if you're cropping. And just to make a note, this part of the soil action plan here that I'm showing now, which is a checklist of field condition, like things like ground cover and root depth and soil stability and perennial pastures, those kind of things, as most of you be familiar with, which obviously a normal soil test can't really help you with. So you've got to use a soil test in combination with sort of monitoring the paddock, so to speak. But so I'm just going to jump straight in. I've got all the tests lined up here, so if you can see, hopefully everyone can see the screen. If you can give me the thumbs up, those of you that are on Zoom with the visual, just so that I know you can see that screen all right. You guys can see that, and you can see that. No one's giving me the thumbs up, so I'm assuming everyone can see that screen. Yep, thanks to Neil. And I'm going to get my thing. So I've got everyone's lined up here, and I've got Rogers as Abbotsford, and then Redcliffe for Frank and Tennille, and Africa's Luke, and the last one there is yours, John, which is Clareborough. So I'm just going to kind of zoom across and jump between them. Now we've got, I don't know how many soils we've got lined up here. We've got 15. So we won't be able to get all of them covered. So when we jump to yours, just tell me the sort of top 2 that you want to look at. We can certainly touch on other ones, but I'm just mindful that if we do everyone's 5 soils, we're going to run out of time for sure. So if we've got about 90 minutes, we're going to run out of time. So I'll just start the process off. But yeah, just let me know which soils you want to look at, and you want to use chat. So John, I might start with you. Which one's the sort of relevant one that you want to have a look at, or which are your top priority ones? And don't say all of them.
For John,
Yep.
John will be a comparison of both because they're both only 15.
Oh, he's only got 2. Okay, that's easy.
He's only got
that's
2.
Good. Yep. That makes it easy.
Why would John? Do you want to explain?
Yep.
One's where there's Mitchell grass is going along all right, and one's where the Mitchell grass is sort of probably, it's died and hasn't recovered.
Yep.
So
and it's not
maybe
fun.
Slightly different soils too. One's a bit ashier.
Yep.
With this, John wasn't with Susie and I when we did this, but these are in the same, like they're only 15, 20 metres apart from each other.
Yeah.
And it's where there's these patches of Mitchell grass that are healthy and patches that are very unhealthy.
That are not. Okay, great.
And we have tended to, like when we're taking the samples, we tended to go more in the actual tussocks themselves rather than, in between the tussocks where the Flinders grass will be.
Yeah, great.
And it's partly trying to work out if there's a problem with the soil, but it could be that it might be curl grub is the issue, but we haven't had that confirmed yet.
Okay, no worries. So to Neil, yours is Redcliffe, and there's a few soils there from Redcliffe, 1, 2, 3, 4, 5, 6, 7. So do you want to just pick 2 that are of real interest to you? Or I know obviously they're all interest to you. You've got a Progardis trial going on number 8. And you've got...
that's the one, number 8. Yep. I think the other one that had some interesting numbers was the Mount Pollux paddock. I'm just trying to call Frank actually to see if he had a preference. So he's not answering at the moment.
That's all right. I mean, we might have time to jump between the other ones, but I'm just mindful if we run out of time, just focusing in on a couple of priority ones for you. That's all.
Yeah, no, I think that will be
8 and 12, and we'll see how we go. We can always look at the neighbouring ones. Okay, that sounds good.
Just check. And what was the difference between the 12 and 13? Because I wasn't there when you did those. Was it?
The one is where we were at the other day with the at the monitoring site, and the other site is only about 200 metres, if that. Wouldn't even be that. It'd be less, probably 100 metres away, but where the bore is, and it's just totally different soil. So like the paddock is 2 different land types, and sample there as well.
Might do the 13 sample.
Yep. So 13 and 8, or 12 and 13.
Yeah.
13 and 8.
8 and 13.
Okay.
Yeah.
Too easy. Righto. Great. Thank you. Luke, what about you? What are some priority ones that you want us to look at?
Yeah, David, 2 and 4.
2
was taking in a horse paddock that's been spelled basically for 6 years.
Yep.
And had very minimal stock pressure.
So,
and then the 4 was a paddock that's had heavy stock pressure close to the water for a number of years. And every year gets a 6-week spell, but it doesn't, it always gets a heavy graze.
Yep.
We just thought we could see if there's any change in the soil, but there's different numbers there. But
Yep. That's all right. We'll have a look at that.
There's a possibility that number 2 had been previously cultivated once before too, possibly about 10 years ago.
Okay. All right. No worries.
Okay.
No, that's good.
Thanks.
Great. Thank you. Yeah, no worries. And Roger, it's hard because you're not on the thing there, but there's only 3 from Abbotsford, so we might be able to get across them all.
Anita's not far away. Like she's home. I think was just jumping in the showers. She'll hopefully be on before you do Abbotsford.
Okay, no worries. Yep.
Yeah, I'd imagine that you're just going to do that shed paddock one, Jan, and then is there one in bottom paddock?
Yeah.
Shed and yep.
Okay. imagine those would be the two for that property.
Okay.
Yeah, and
6 and 8. Yep.
Yeah.
Righto.
Oh, here she is now. She's just coming through now.
Okay, so I'm going to jump in, guys. Anita's coming in, but I'll keep rolling. So the first thing that we're using that we can do to sort of assess the soil is decide or determine what our soil type is. So that's that first key thing you can use a soil test to. Instead of just saying it's heavy brown stuff or brigalow country or whatever it is, we can just sort of say, yes, it's a heavy textured soil with low fertility or high fertility, and it has a charge in it. If you remember, soils have a charge in them, what's called a CEC. So I'm going to start over on the left-hand side with your soil there, Luke, in Africa. We'll just pick on number 2, which is column H. So I just better get my squiggly thing going tonight. So hopefully everyone's got their results and you've got your worksheet. But if I just start with your soil here, and we go down, I'm looking for the total fertility to start me off. So this overall soil type is really the first part of your soil type is what's the overall fertility in the soil. And that's what we find on that second page down the bottom. We've got this totals analysis that's been done for you. So this totals analysis is not a standard test, it's additional to normal agronomic tests, but it does help you understand your soil type because the long-term fertility potential, particularly in pastoral country, is coming pretty much from the soil. So your first soil there, Luke, is number H, and we've got, hang on a minute, where are we? Phosphorus. So that soil has a total phosphorus of 77, the total phosphorus. And the number 4 soil, which I think is J, has a total phosphorus of 68. So all you other guys, if you want to have a look across your soil tests and just evaluate your total phosphorus, I think L is your one, Roger. So that's 3. So your first soil there on that one there on Abbotsford is 371 total phosphorus. So you can see, Luke, there's a big difference in those soil types between those two on your place and that one on Abbotsford, which has over 370 total phosphorus.
Yeah.
Yep.
David, that's good. You just keep talking. I'm just going to stay muted because we've got the kids in the background, but thanks.
All good.
Keep talking.
Yep, that's all right. Yep, terrific. And then the other soil over there on Abbotsford is that second paddock that we've nominated, which I think is N, and that one there is 457 total phosphorus. So we could do the same for calcium. So look, you've got, even though you've got quite low, you'd say very low phosphorus in that first soil type, but your calcium levels are extremely high, which we know is very typical for that area of Australia. So there's very low phosphorus, but the calcium is extremely high, and the same with those 3 soils. The only difference is K, just looking at that really quickly, even though it's not on the nominated soils list. K has a total phosphorus, so that's Africa, that's the scrubby front paddock, and K has a total phosphorus of 90, where is it? Total calcium of 400. So you can see that scrubby paddocks are very different mineralogy in the soil there. So it just gives you a feel for total fertility, and in particular, obviously, phosphorus is a key nutrient in grazing landscapes. I mean, you need all the nutrients, but we know that phosphorus is a limiting factor for productivity, and sulfur as well at times can be. But you can see also in this landscape, it's inherently, this soil number K is inherently, it's your last soil on your list there, is really low in fertility versus all the other soils. And if I compare it against Abbotsford, which is next door, it's really low against them as well. So if we come over to the soils at the other end of the chart, or just hang on, bear with me, everyone. I'll keep moving across, and we'll come over to, where are we going? Red Bank. Where's Red Bank? Now I'm getting myself confused. Redcliffe, sorry. Redcliffe, and we're doing 8 and 13, I think. Tennille is what you're after. So 8 is V. I'm just writing this down as I go. And then AAA.
Just sorry, when you're talking about phosphorus, like where are we putting that? Is that for the charge?
No, this is the total fertility. So on that worksheet, sorry, I probably jumped across there. So on step 1 of your worksheet, I'm just doing a brief assessment of the total nutrients. So the 3 parts of soil type are total fertility, CEC or charge, and texture. So I've sort of started at the last one. Yeah, sorry about that.
Okay.
So so if we go down, so your V and AA for those 2, and while I'm there, I'll just get the last one there which is AB and AC. All right. Sorry, that way I can jump around. It's a little bit tricky with all these soils on the one. So that's Tennille. What we're doing is looking at total fertility first, which is part of soil type. And so your soil there, the V, coming down to V, if I can get that focused in on that one, you can see here you've got 30,000 total calcium. So in all my years of reading soil tests and totals on soil tests of soil types, that's the highest I've ever seen for calcium. So this is a really, really high calcium soil. And you can also see it's really, really high in sulfur. Notice how the sulfur is compared to, this one's pretty high, but you can see here less than 50 total for sulfur, less than 50 total sulfur. And over here, we've got a couple of really high ones these are all your soils. You're really, really, really high in sulfur. So at 3,000 total sulfur, there's not many soils in Australia with more sulfur in them, basically, and there's no soils in Australia with more calcium. And that's because it's probably a gypsic soil. So the gypsum mineral has formed in that soil over geological time. That's just the nature of that soil type. And if you have a look at, if everyone looks at the other soils, you can see here that the sulfur levels on those soils on Abbotsford and Africa, they're much, much lower. So and so your phosphorus on that soil type, so if I'm just picking on the 2, I mean, calcium's really high, the sulfur's really, really high, and then the other thing is phosphorus, and your phosphorus at 500 is quite high for phosphorus. So there's a bit of phosphorus in that landscape. So the low phosphorus grazing country, you're usually talking less than 100 total phosphorus, usually that sort of ballpark. Inherently a really high fertility soil. And if we come across to John, to the AA one, so number 13, you can see it's got a similar pattern. It's got oodles of fertility in it as well, not quite as much. Doesn't have nearly the same amount of sulfur. See how it's only got 260 sulfur, but it's got heaps of all the other nutrients and a fair bit of phosphorus. So I'd suggest to you that number whatever it is, number 8 is a gypsic soil. So gypsum naturally forms in arid areas under certain mineralogies. So it's a high, what we call a gypsic soil, which is really high in the gypsum mineral. And that's why you've got calcium and so much sulfur, because gypsum is calcium sulfate. And then if I come over, so I guess in a nutshell, you've got really high fertility in those soils compared to the first 2 soils that we looked at Luke's and Rogers there and Anita's. So hi Anita, sorry you've jumped in. So hopefully it's making sense to you as we go. We're just following our the sort of soil action plan, and the first part of it is just looking at soil type, which is the total fertility, the cation exchange capacity, or CEC, which is discharge, and then the texture of the soil. So if I just go and finish off on yours, John, which is A, B, and AC, you can see from the totals down in the total section that you've got sort of good levels of calcium, all the other ones there. And if we just focus in on 2 of the critical ones, sulfur and phosphorus, you can see that you've got a fair bit of phosphorus, comparatively speaking, around that 300 to 400, which is not bad for phosphorus levels in soils, total phosphorus. And you've got a bit of sulfur at 100, 130, and 67's on the lower end of things, but it's not drastic. As you can see over here, this soil here, number T, whoever's that one is, it's got less than 50 sulfur. So that'd be what you call a really low sulfur soil. So yeah, your calcium levels are good, your phosphorus levels are okay, and your sulfur levels aren't too bad, and all the other nutrients, the magnesium, potassium, all these other elements are fairly abundant. So basically, this first step is really sort of telling you this long-term potential of my soil, and it'll particularly highlight for you if you've got a soil type that has low phosphorus. So as you know, there are land types across northern Queensland that have low phosphorus, and it's a problem for production. So this kind of a diagnosis, getting the totals, just helps you understand that. And so overall, most of the soils are showing a fair bit of phosphorus, although there was that really low phosphorus soil back over here. Whose soil was it that was winning the chocolates? Yeah, you've got a couple over here at 60, at 100, 68 and 32. Oh no, that's the wrong one. 168 and 97. You'd consider that to be very low phosphorus. So those soil types there, I, J and K, you'd consider them to be in the lower end of things. Yep.
David?
Yes, Anita.
What's considered low sulfur? Sorry, I just
yeah, so no, you're right. So we're talking, so here's the sort of, if you look here on this side of the EAL test, they've got kind of general ranges. Sort of, they're not really benchmarks because it's just geology. So you can't sort of say, oh, it's good or bad. You can just sort of say it's high or low because you've got to manage it. So like sulfur, you'll see sulfur below 100. Here's the sulfur range here. And you can see they say 100 to 1,000. So all they're doing is they're saying that across geologies on planet Earth or in Australia, this is the kind of range that you'll get. There hasn't been a lot of study done that I've seen. I'm happy to sort of stand corrected, but I haven't seen a lot of study done on the influence of sulfur on production of grazing beef cattle in the northern rangelands, or the wet dry tropics. I haven't seen a lot of studies done that. We know that sulfur can be limiting at times, but there hasn't been a lot of work done on it. They've done lots of work on phosphorus and a bit of work on nitrogen, but no one's ever, what I've seen, really ever done much study on it. So when we get to available sulfur, you'll see that, it's a bit problematic, and often people will supplement. But yeah, if you're below 100 total sulfur, then I'd suggest you that landscape is naturally a low sulfur landscape.
Yeah, I think all three of ours were below 100. And
you can see the ones over on to Neil's that are really high because it's a different mineralogy there. And so she's got luxury levels. Neil's going to have other issues later on, but she's got plenty of nutrients there. But there'll be other aspects of that soil that may be problematic for her just because of that gypsum.
So if sorry.
Yeah, you're right. Go for it. Yeah.
Like we breed sheep as well,
yes,
and have a bit of issue with tenderness in the wool, which we usually lambing or storms or other things. But could the sulfur potentially be a limiting? Definitely
a weak link because it's important for protein formation in wool. So definitely, and so that's obviously genetics and all the rest of it come into that strength of the wool, but sulfur is a key element for protein in wool. Absolutely. Yeah. So, and that might be strategic supplementation, but yeah, it does come right back to this basically, especially if the animals can't move, which in the modern world with us putting fences up everywhere, whereas in nature, well, before we come along with sort of modern agriculture, they would have just roamed seasonally, and had a mixed browse, and they would have been able to self-balance. They would have gone to known spots for getting things at different times of the year and all the things that wild animals do, but they can't do that anymore. So yeah, and it's like phosphorus. If you've only got low phosphorus country, you're always going to have that problem, and it'll flow through the animal enterprise. Yeah. So definitely, yeah, I'd say it's highly probable that it's part of the story with the wool strength. Yep.
Yeah. Thank you.
No worries. Okay, so we've looked at totals, and there's no sort of it's not like a sorry everyone, I'm just trying to get my screen sorted out a bit better. It's not sort of a wrong or right thing, but I guess you're just giving yourself a feel in this section here. Just write, okay, I have fairly high fertility. I might have a weak link like sulfur, but I've got pretty good levels of everything else. Or you might say I've got really high fertility or moderate fertility. So it's just making, as you can see, just making that observation. I don't know where all my soil tests are gone. Hang on a minute, everyone. Here they are. What's happening? All right. So now the next thing to do is to look at this charge in your soil, which I'm just trying to find, which is about halfway down, and it's this term here. For some reason, my soil screen is not doing what we want it to. So it's about halfway down. You'll see this term here, cation exchange capacity. Someone's just come in on a phone. Can you mute that phone? And just because it's really throwing my brain out behind, sorry. Thanks for that. So,
yeah, sorry.
no, you're right. I'm sorry. Just like it absolutely throws me out. It's the same in face-to-face workshops. If someone's talking, I just lose concentration. So we're looking at CEC, cation exchange capacity, and that's measuring this charge in the soil. And if you're, I think hopefully everyone remembers, it's like milk. Just think of milk. It actually has a charge, believe it or not, in the fat. So it's what we call a colloid. And your soil types in that part of Australia, naturally, usually most soil types have a high charge. So 40 is large. So 5 and 4 and 3 is a small charge soil. It's not good or bad. It's just what you have. It's a bit like saying, I prefer clay soil to sandy soil. They're just different. So as long as you manage them within their capability, they're not good or bad. They're just different. They've both got their pros and their cons. So in this case, all of your soils here across this first one here, which I think is your, whose is the first soils up here? This is Luke's, I think. Is it Africa? Yes. So you can see there that they're all large charged soils. They're over 40, 50. So they've got a very big charge in them. And that's coming, Luke, from the, just go down to it again. That's coming from the clay content. So I'm pretty confident in saying that those soils are quite heavy clayed soils. So I don't know why that's doing that. So they're pretty, it's a pretty heavy clay type soil that we're dealing with on those soils. Is that going to work? No. Okay, sorry, that's throwing me out. So we've got that 44 to 50. And then we've got this soil over here, number K, that you can see is 4.1. So I'm going to guess that that's a sandy soil type. Am I correct in that? I don't know whose soil that is. That number K.
Yeah, that's correct. Yep, sandy.
Yeah, yeah. So Luke, that's got almost no clay in it. So, and the only other thing that will give it some charge is organic matter. So it's a very different soil type. So it's for grazing, obviously, you know, as you know, that kind of country, or those two different types of country respond differently to rain and the rest of it. The real difference with CEC is if you were thinking to crop that country, you'd fertilize it very differently than the other soils. So if it's grazing country, you probably already know that it responds differently. I'm not telling you anything new, particularly to rain and maybe to ground cover and the types of grasses that are growing. They're all probably going to be quite different. But other than that, the CECs, because you don't use inputs, the CEC is not going to be that relevant. If you're going to crop, if any of you guys have got paddocks, which I think there's a few that you're trying to crop, or you're thinking to sow legumes into, then that's where just be mindful that the different legumes like different soil types. If I go, just get my bearings again. Sorry, everyone, there's that many soils. I've just got to every now and again calibrate myself. So the next one's Roger and Anita, that's 6 and 8, which is L and N. So if I go down again to our CEC, you'll see that your soils again have this really large charge in them. So I'm again assuming that they're going to be a fairly heavy textured clay, cracking type clay, and they've got this large charge which reflects that. But again, if you're not going to be cropping that, then it's not that, you know, it's not something you have to worry about. It's not good or bad. It's a large charged soil. But if you were to crop, and if you're choosing legumes, you make sure you're choosing legumes that like the heavier soil types, basically, is the key message. And then we go across to the next soils, which is 8 and 13, V and AAV. Sorry, everyone. I think I've got everyone. Just let me know if I'm missing someone, because it is Friday night. And V, hang on a minute.
There'll be Rowan has joined us, although he's trading under Alexander. But yeah,
which give me. I'll come back to that one. Let me keep going on the road.
That's a separate. That's the
the other test.
Yeah, the separate.
Okay, great. We'll go over that in a minute. Okay, so if we're looking at Tenniel at Redcliffe, so we've got we've got, again, a really large charged soil, Tenniel, and your A's 41. They're all large charged. They're heavy clays, and they're full of a gypsum mineral as well. So they're full of calcium sulfate mineral, or these ones are, So, we know it's heavy clay. If you're not cropping, then it's not that much of a worry. We don't worry too much about it. And those last two there, John, are the same. They're large charge clay soils that are cracking, so which is the Mitchell Grass Downs main soil type. It's just when you get those sand ridges or whatever from old rivers or wherever they come from, that you're getting that really unique soil type. So we know our CEC, they're big CEC soils. If you think about the granite belt, say I used to live on the granite belt near Stanthorpe, the coal country, on doing vegetable agronomy, and a lot of those soils have a CEC of 2 and 3. If you go to Fraser Island, where there's beach sand and they grow, the forest grows on beach sand, it's got a CEC of about 2. If you put a bit of organic matter in it, it might go to 4. So you can sort of get a feel for it. You've got very large charged soils. All right, let's look at the last part of soil type, which is texture. We can do that really quickly because I'm pretty sure you guys all know your texture of your soil. Remember that texture, which is down toward just before your totals, texture is the sand, silt and clay content of your soil. And you guys sort of know that you've mostly got clays, and you might have a bit of river country that's a little bit lighter. So it's got maybe a bit of silt in it, so it's called a loam. But then you've got your sand stuff that's sort of the outliers. But in general, you've got these soils that are mainly got clay in them. So again, if you're not doing tillage, or you're not, if you're not trying to grow crops, it's not that important, but it does influence water and how much water is held in the soil. It has a strong influence on that. But whatever grazing landscape you're on, you've got to maximize ground cover and perenniality if you want to improve your water cycle. Okay, so now we've kind of just looked at soil type, which we kind of knew. We've mostly got heavy clay soils that have a large charge, and some of them have a lot of fertility. Some of them have not so much fertility, still reasonable, and the sandy country will be low. And as you've noted, Anita, you do sometimes have a weak link nutrient, what I call the weak link nutrient. In your case, it's sulfur. So we know, we're always in the back of our mind, we're thinking, okay, on that land type, sulfur is a weak link just because of the soil type. So now we jump into the soil health checklist. So if I just get that scorecard out again, now we're going into our soil health checklist. So here's a little table. And if you remember, the tricky part of soil health management is benchmarking, like what's the good level of organic matter to aim for, etc. But all we're doing is we're finding the level of our organic matter, our carbon to nitrogen ratio, which is the quality of our organic matter. If you remember, it's kind of like, is it too woody or is it too green? It's a bit like digestibility with animal feed. So we want that to be in a reasonable balance. And then pH, which you're not going to change anyway. Where you guys are, you're not going to change it. But something that may be important that you just need to be aware of, some of these soils might have salinity. So we'll explore that, because definitely the other group had some of those issues. And sometimes the other thing that's relevant for your area of the world is that some soils have really high sodium. So that's not exactly the same as salinity. They can be related, but that's sodium hanging out on your clay, which is different than salts. So salts are kind of in your soil, your available pockets in your soil, whereas sodium kind of hangs on the clay, and it causes a lot of problem when it's at a high percentage. So let's jump through the checklist. I'm just going to go down the checklist on your soil tests. We're going to look at organic matter, carbon to nitrogen ratio, and then salinity and sodium, because they're the main ones for your part of Australia that are relevant. And the key thing to remember is that when they're outside your benchmark, when they're either too high or not enough, like if I don't have enough organic matter, I've got a problem because I need it for water holding, I need it for nutrients, I need it for nitrogen management. So if it's outside our benchmark, then we've got a problem. So when we have a problem, we put a grumpy face, and a grumpy face means that I'm probably got an issue that's holding back productivity on that landscape. I've got a soil constraint that is probably limiting my 3P grasses and production. And the other issue that it's useful to know what if you've got a soil constraint is if you're trying to sow legumes or progrades or whatever, and it's not going well, or you've got bare areas and you want to know why. So this is what we're doing. We're trying to troubleshoot now. Is the soil the reason that those bare areas are there, or is it just because of a grub, or is it for some other reason? I was on a property the other day and they're trying to sell it, and someone's been dumping chemical herbicide in patches. And all over the place there's this bare grass from, obviously for some reason, who knows why, they were sort of emptying tanks in different spots. Okay, so let's start with organic matter, which is near the top of your test. So it's kind of about a third of the way down. Sorry, this keeps jumping, this mouse. A third of the way down. Here it is here. Estimated organic matter, about just a third of the way down the first page of the test. I'll go over to the end of the test and start from the, hang on a minute, start from the end, start from the beginning, sorry. And so we've got our first soils, which are Africa, and we've got 2 and 4. So if I get my organic matter, you can see here, that's H and J. Sorry, hang on a minute, everyone. I'll just put H and J there. Okay, so you can see there, Luke, that your first soil, number 2, has an organic matter percentage of 1, and your number 4 has 0.84. So you can see that they're quite low. They're quite low levels of organic matter. This soil in particular is really low in organic matter, so it's not holding very much water. Is that the sandy soil? Is that the really light sandy soil?
No, the sandy soil's 0.85.
That's this one.
No, it's the next one long, but it's yeah, they're both black soil, probably only taken 2 k's apart in the same. But yeah, like I was saying, the one is a horse paddock that's been spelled and got a lot of organic matter accumulated over probably 3 or 4 years. It just always has heaps of organic matter, and the other one's always grazed reasonably bare to within 30% by the end of the year.
Which one's that? Which one's that?
Number 4, which is the
J.
first.
Yeah.
K. Yep.
So the one with the lower organic matter is. Oh, so are you talking about J and K, or 4 and 5? Or are you talking about 2 and 4?
2 and 4 I'm talking about.
Yeah. So 4 is the one that's grazed a bit heavier than 1, 2. Yep. So it's sort of reflecting in the organic matter. But having said that, in the soil organic matter, 2's not great either. So I think I gave you guys a benchmark of between at least 2 to 3% organic matter for that kind of grazing country on those soil types. So yeah, they're definitely low. You can see your first soil. I don't know the management there, but you've got 4.4 in the first soil. But I think getting to 2% and over is a reasonable target. So I'm putting a grumpy face on these guys. Sure.
Yep. Thanks. Yep.
And obviously that's all right. I'll sell you some brown coal to fix it too.
Oh yeah, sorry. So you can improve that by just less grazing into that area, or is it not as easy as that?
Yeah, grazing management. Yeah, so not necessarily less grazing, but timing that pressure on and off. Definitely. Yep. So the key thing that helps build organic matter is root volume. So the more dense your perennial grasses are and the bigger root systems they have, the more organic matter you'll have. So that's the 2 key things. The more closely together the perennial grasses are growing, so less bare ground between the grasses, and the bigger the root volume. And the way to build root volume is after grazing, allow the grass to recover for some period before you graze again.
Yep. Gotcha.
So you
can
can.
How you do manage the first paddock?
Sorry, Anita, can you repeat that? I missed
how
that.
we manage the first limestone paddock, it says.
Yeah, the one with the 4.4.
Hasn't been grazed for probably 8 years, but it has got a horse in it now out the front of the house. It's on a limestone ridge and it's got buffalo in it, and it's it hasn't been grazed for a long time, but it has this year for the first time in a long time.
And bit different soil too, isn't it?
Definitely different soil. It's only got about a foot of probably 8 inches of black soil, then it goes straight into white gravel, like you use on the road base around here. The rest of that country's probably more 4 foot. The number 2 and number 4 have got 4 foot of black soil before you get to the white gravel base. And
but you can see, like, it's got even higher calcium than one of Tennille's paddocks. So at 52%, 52,000 total. I'm looking down at the totals on that soil number 1, and but it doesn't have the sulfur that Tennille's has. So that tells us that that's a lot like limestone. Obviously, that's why they're calling it that. That's calcium carbonate rather than gypsum. In that soil. But yeah, it's a good example, I guess, for us tonight, because it's telling you that, you know, it is possible. I know the grazing management's critical, but it is possible to get over 4% organic matter in that area of Australia, you know, with pasture management. So whether you can make money out of that or not, that's the second question, you know, whether you can graze them productively. And
David, after you commented on this one previously, I was wondering, because when we were doing that core sample, we were going down through the black soil and then went and hitting into the white calcium at the bottom. So whether we should have just pulled up as soon as we got into the white.
Definitely, yeah. So if you've mixed the calcium carbonate into the soil sample, that spiked the results for sure.
We might have done that, hey, Luke?
Yeah, we definitely did that,
Okay, well, that explains it, because that's through the roof. And I don't know about Tennille's paddock, if that was a deeper topsoil. So yeah, that's gypsic. Yeah,
no, that was different in Tennille's paddock.
Didn't have that horizon, that wide horizon.
Definitely not.
Yeah, great.
Just on that note, David, when you are taking a soil sample, what's the depth of the actual soil you want to be testing?
Yeah, so my opinion in your part of the world is the root depth of your perennial grasses. So if you're not, I know they can go really deep, but the main root depth where most of the roots are. So if you go out and dig up one of your better grasses during the prime growing time, and you know, they might be going down 30 centimeters, 40 centimeters, 20 centimeters. That's the kind of relevant zone then to take your soil sample. That's how I see it, because that's where they can get to realistically. Often in pastures in sort of more inside country or, you know, higher rainfall country, people do 0 to 10. But yeah, I think you guys are trying to manage a landscape with perennial grasses. So let's see where what they're in their feeding zone, what's happening. That's my logic on it.
Gotcha. Yep. Good. Thanks.
No worries. Okay, so I better keep jumping across now, because as you guys can see, there's a bit to all these soils. So we've come across to Abbotsford, and we're looking at L and N now. So I've just sort of gone sideways, L and N. So Anita and Roger, so you've got that first soil there, 1.4, and N is 0.97. So my 2 bobs on it is, I think if you're not close to 2% or above in that kind of grazing country where you guys are, I think you've got a soil constraint. I think you're losing potential water holding capacity, soil structure. All of those things have been compromised if we're under 2, even 3% on the better soil types. So obviously the main tool you've got is grazing and control of grazing and rest, allowing grasses to rest strategically, which is a big topic in itself, but I know there's plenty of extension round for that.
Yeah, no, totally agree.
Yeah. So that's those 2. So I'll keep going over, because I think now everyone's got a feel for this. So if we go over to Neil's, I think you're next cab off the rank, to Neil, with V and AAV. Yep. So
2.9 and 3.1.
Yeah, there you go. So you've got a fair bit of organic matter in those 2 paddocks in the soil. 2.9 and is it AA? Yeah, 3.1. Yeah, so you can see they're quite good, those soils, with their organic matter content. For sure. The key thing with sandy soils, those of you that have a sandy soil type somewhere on the property, is that you'll never get the same level of organic matter as the heavier clays. Clay in the same area of rainfall and climate, clay soils can build a bit more organic matter than sands can, and it's a soil physics issue as much as anything else. So they're quite good. So, you know, I think they're reasonable to Neil. So the big challenge is how to keep them there and not let them go backwards or anything like that. and can I increase it some more? And this is the big question we've got here, obviously, is how far can we increase organic matter, and do I have to increase it much more? What's the extra benefits? Okay, it helps me with water holding and soil structure and helping so the roots can go deeper because there's better structure. But yeah, there's an economic sort of decision you've got to make. So not too bad at that, like compared to most of the other soils in the project. They're looking really good. And then John, those last two across there. So yeah, that second one is, you can see it's quite a bit lower organic matter at 1.5%. It's not really through the floor, but it's definitely lower than the previous one, than the first sample that you've got there. And the other thing that comes into this that I think we mentioned was that if you take the sample from between plants, in the bare ground between plants, that will give you one result. And if you take the sample right next to the tussock grass, like literally next to the base of the tussock grass, there's going to be a bit more organic matter in the sample when you get it back from the lab.
And
so
what these two were, David, like Sophie and I took them, the one in the healthy, both, we put them into the virtually right at, on the mound, the tussock sort of itself, and went right there.
Yeah, great. So that's telling you, that there's a bit more in that healthy paddock. But whether that explains why it's...
They're right beside these patches, aren't they, John?
Yep.
Yeah, like they're these distinct patches, and we're just trying to rule out, well, whether there's the influence of soil or whether it is these curl grubs, but it's...
Yep. I wouldn't think that organic matter's the influence, so we'll keep going on the checklist. Yeah.
Sorry, David, it's Tennille here.
Yeah.
Just so when you're doing those samples, do you do it in the bare patch or do you do it on the grass?
My two bobs on it is to do it next to the tussock grass. So, but if you've got 70% bare ground, like, as you know, that, you've got condition D type country, you've got a lot. So you could get really mathematical and, get all the ecology design going and all that stuff. But basically, if you're just sampling the interspace between plants, you're always going to have a lower number. So as long as you keep doing that everywhere, you're kind of comparing apples to apples. But it's just be really careful, because when they did the grazing land management technical research back in the, it was early 2000s, that was a clear thing they discovered, that, well, they knew, which people knew anyway, was that close to the perennial grass and right under the perennial grass is a lot more organic matter, like 3 or 4 times more than 10 centimetres away in the interspace. So,
question, David.
Yes, Anita.
Sorry, with the organic matter, our middle test was actually in like A to B land condition country. And it's got a middle result, like it's between the other two at 1.1. And we were also actually sampling more towards the tussocks. So I don't know whether, that paddock has not been rested, whether, is the soil health deteriorating despite there being tussocks there?
Yeah, the challenge I have, Anita, is, and as we kind of mentioned in the other workshops, is the problem. The problem with just looking at this number on its own is that we're not looking at the whole picture holistically in the paddock. So and so it's just part of the story, because sometimes you'll have an average result on organic matter or pH or something or whatever, and you'll go in the paddock and the paddock's actually going really well. And this is the thing about soils, is that they're complex. So just because one number's average or poor, you've got to look at everything else to get the full picture. It's like the doctor saying, oh, you got a temperature, I'll give you an antibiotic. You've got to look at everything before you make that decision. And so, obviously you're just telling me that other indicators of land condition are good. So, and if you then tell me that the grasses grow pretty well, they respond to rain, the cattle do all right, then I'd be saying, okay, well, yeah, you could probably improve it, but it's not too bad. So it's not the only number we should focus on. It is an important number, and also how deep you sample. That's the other thing as well. How deep are the roots going? That's the other thing that obviously we're looking at as well, because you can have organic matter of 10% in a grazing paddock on the coast, but the roots are only going to 5 centimetres because there's compaction. And so that paddock, the soil test will say 10% organic matter and everyone gets excited, and then you go and dig it up and it's like, this has got real problems. So yeah, you got to use it. Look at it in the context as well. But yes. Okay, so that other number, so that's telling us how much organic matter. So hopefully you can sort of make a note for yourself on the soil test, you know, am I okay? Am I marginal? Am I good? Because that, you know, that sort of giving you a rough rule of thumb how the grazing's going, or is the paddock need a bit of improvement, or is it okay? And it's just another thing in your condition list, if you like. And then we look at the carbon to nitrogen ratio, or C to N ratio on the soil test. So if we get that one up, that's down towards the bottom of the test, the bottom third. So if you come down to just above your totals, just above the totals, you've got this next to texture, you've got this C to N ratio. And not sure if you remember, I think I did send through a benchmarking sheet. Hopefully I did. I'm pretty sure we had a benchmarking sheet, Anne, or not. Yes, we did. No, we didn't. Maybe not. Anne's looking confused. Don't worry.
I'm not sure.
Mate, that's all right. I think, but the benchmark I gave everyone was between 10 to 1 and 20 to 1 for that ratio. So if you have a look along the soils, I can do all the soils at once here because it's a pretty straightforward ratio. Does everyone see above my marker there? That's your result above the line, not in the line, obviously. So this first one here of yours, Luke, this one here is 26 carbon for every 1 nitrogen. That's what that number means. 26 to 1. So if we go over to these ones down here on Abbotsford, it's 14 carbon for every 1 nitrogen. So I want you to just have a look at your soils, and the only one that I can see so far that's outside. Okay, so what's a benchmark? If your soil is between 10 to 1 and 20 to 1, so as long as it's between 10 to 1 carbon and 20 to 1 carbon, the soil organic matter quality will be okay. So have a look at your results and see if you're between 10 to 1 and 20 to 1. And as we scroll over, if I can scroll over, they're all coming in to the range, which is what I kind of expected. Although we've got one here kind of marginal, this Z one here, which looks like it's on Redcliffe, is it? Yep. So that one there's a little bit marginal. So what that's saying to Neil is that it's got a little bit more nitrogen in the organic matter than usual. So it's got a little bit more nitrogen than normal in that soil for whatever reason. So I'm not sure what the management is in that area. It's grazing, but it's got, but it's not, I wouldn't say it's not a problem or anything, but it's just got a little bit more nitrogen. As everyone saw, the other soils you can see, the ratio is a little bit different. And the only other one that's kind of outside the balance is this first one. So Luke, your first paddock, which is the limestone paddock, has really high carbon in the organic matter. And the consequences of that is that when you get too much carbon in your soil organic matter and not enough nitrogen, you slow down nutrient cycling. To Neil, definitely that could be from Pro-Guardies, definitely, if there's quite a lot of legume in there. But if I just come back to this one, Luke, so this is typical of a woody or forest where you get a lot of woody litter and leaves and twigs and, you know, that build up on the ground of really woody material that's low in nitrogen. And so that 26 to 1 is telling me that paddock is, Dick Richardson, I don't know if you guys know Dick, but he would say that paddock is going to it's lignifying. So it's too much carbon. So the consequences are that you slow down nutrient cycling. So buffle grass, when buffle gets rank and old, and you know how you get paddocks of buffle that shut down. One of the reasons they shut down is that there's no more nitrogen in the topsoil, and there's bugger all nitrogen in the topsoil because there's been no legumes for 20 years or whatever, and therefore you get this high lignin, rank buffle feeding the soil, lots of carbon, and the whole show just goes into slow motion and it becomes unproductive. So
so that's that one I was saying hasn't been sort of grazed for 8 years. So
interesting that's happened. Correct. So I'll probably get into trouble, but if you can't get animals in there, a cool fire would be, you know, like something just to refresh it. But just something to disturb it, basically. But in the midterm, obviously, legumes and, you know, part of the natural cycle of those landscapes was the acacias in the, you know, the mulgas and the acacias in the landscape that naturally bring nitrogen in, as well as your legumes. So yeah, that's what obviously the Progardes and the other Desmanthus are too. But yeah, that might explain why that one's a bit higher than the rest of them.
We've got some heifers we can send you, Luke.
Righto, Nita. Yep. As long as you give them some protein supplement while they're eating that buffle, you'll be all good. But yeah, if you can get some mouths on it, that's obviously the best thing. But yeah, somehow refresh that. Just pulse that system. So you don't want to overheat it, obviously, if you're using a fire. So yeah, so that's that could be going on there. That sort of makes sense.
Yep. Would that be a good indication for fire? Like if it would that be the only one you could use for an indication for fire? Or is there plenty of other samples, other
yeah, for me,
other things in the sample there that you could look at?
Yeah, not really. So it's more looking at the actual landscape, and you guys know that country much better than me. It's looking at the vegetation and, you know, is it, I guess, when it shuts down because it's underutilized, or when there's woody thickening and you want to open it up a bit. Obviously, fire is one tool in the toolbox for that. And I guess that's what the Koori fellas used for a long time to keep country a bit open. And I guess you can take it to the extreme. And if you burn it every year, yeah, you'll get green pick every year. But what'll happen is you'll just burn off all your carbon over time, a bit like overgrazing. So burning every year for grazing is the same as overgrazing with cattle. But in this case, it's probably just hasn't had it's had too little utilization, probably is where it's gone.
Yeah,
and
that's right.
And because buffle can tend to, as you know, get rank, and we had love grass down at Stanthorpe. That's the equivalent down there, and it just shuts down paddocks. Yeah.
Yep,
So,
thanks.
no worries. So hopefully everyone else can see, you know, that example is a pretty good one, and how we're benchmarking. So 20 to 10 to 1. So I'll keep moving because I'm mindful of time, and yeah, we're getting through it. We are getting through it, but there's a bit to cover. So what I'm going to do now is another quick one, and that's because you guys can't really influence it. So the two things you can really influence with as graziers up your way is organic matter and carbon to nitrogen ratio. And the way you can influence the level of organic matter in your soil and the quality of it, like is it too woody or is it in a good balance, is through grazing management and legumes. If you can get legumes in the landscape and graze them well, then that'll help keep nitrogen cycling through the system, keep your organic matter over 2%. So it is a good rule of thumb to monitor, but Anita, it's not the only number too. So going out there and looking at those other aspects of land condition, you've got to look at everything holistically. So the other one to quickly look at is pH, which is near the top of about a quarter of the way down your first page, depending on how your printouts come out. And I'm just going to underline it. So it's the number above that line that we're looking at. So I'm just going along. So you can see here the first soil is 8.5. And if I go along the soil samples to the other end, I'll try and get to the other end because we've missed the other end a little bit. So I'll go along to the other end. You can see here, you guys have your pHs along there as well. So you can see here that almost all your soils, or all of your soils in that part of the world, are over 7, which means you're alkaline, which you probably already know, and you're not going to do anything about it because you can't go out and change the pH. Well, you can if you're Gina Reinhardt, but you guys aren't going to be that silly and get a checkbook out to change the pH. So the main reason to know your pH is if you're thinking to sow legumes, whatever they are, make sure the legume is the right fit for the pH of the soil. So some legumes, the ones that have been trialled up there, like Desmanthus and what's the other one? The secas and things, they are usually adapted to those soil types. But if someone says to you, I've got this brand new legume, or here's a new variety, just check with them that it's a good fit for your soil pH. That's the main thing. And if you're thinking to do crops like sorghum or something, most of those northern cropping zone crops are pretty tolerant of high pHs too. So, but just that's the only reason we worry about it, because you're not going to change it if it's really high. But it is, your soil types naturally have really high pHs high to very high. So 9 is very high, John. But and so that, you know, there are grasses that are tolerant of that pH, but getting to 9 pH is starting to get at the upper end of things. So there's not a lot of things that are happy over 9 pH. So, you know, this is maybe kind of indicating part of the problem, but yeah, we'll still keep going to see if we can troubleshoot this soil. But yeah, it is, you can see it's at the upper end because pH of 9 is definitely really high. Excuse me. But a lot of the grasses and landscapes up there, they're tolerant of a pH of that 8.5, you know, because it's the natural pH for a lot of areas. But yeah, maybe creeping over 9, you know, it's starting to be a bit problematic. But I guess now the question is, why is it creeping over 9, which we'll try and get to. Okay, so we've done pH. I'll just get the checklist up again. So as we're working through here, we've looked at organic matter and we've scored it. We've looked at the carbon and nitrogen ratio and we've sort of made some decisions around it. We've just checked pH. The next thing we can do is look at soil salinity. And soil salinity is, hang on, it's not clearing. Yep. Soil salinity is on your soil test. I'll just get it back up. Soil salinity is just next to your pH. So if you go to your soil test and you have a look at this thing here, just below pH, it's called electrical conductivity. So let's have a look at some, so maybe because salinity is a little bit tricky, what I'll do is I'll go to the benchmark. So if you have a look over on the end of your soil test where the benchmarks are, you'll see here that they've given you benchmarks for electrical conductivity based on your soil texture. Everyone notice up the top in this section of your benchmarks, they've got soil texture types. So I'm going to call most of your soils clay, except obviously for that sandy soil that some of you have got small patches of. So if we just use clay, they're saying that if you're over around 0.2, then it's starting to get salty, okay? Too much salt in the topsoil will inhibit plant growth. So salt bush and blue bush sort of like it, but a lot of other plants don't. So let's start from the other end and have a look. Oh, no, hang on a minute. I'll just throw everyone out by starting from this end. So if we start from your end, John, and we go backwards, you can see here that if that's a heavy soil type, then it doesn't seem to be too salty. That makes sense. So it doesn't look to me, Anna, and that salinity is causing the problem there. Because that salt
what
doesn't...
would be a really... what would be one that... 0.3,
0.4, 0.5. So around Charters Towers, you get soils like that on some of that really problematic soil that erodes away. And yeah, you'll get that really high, and it's bald and nothing grows. Yep. So yeah, I don't, my gut feeling is telling me that salinity is not the limiting factor causing that bare spots or poor growth. If it was 0.3, I'd say yeah, it possibly is, but doesn't look like it to me. So as we come across, you can see the rest of them. Here's one here, bang. So we've got an extreme soil. So to Neil, I know you were pretty happy that you had all that calcium and sulfur in your soil, but have a look at your salinity levels. So your salinity level is 10 times John's. So John, that's an example for you of a soil that would have problem. If you had bald areas, you'd be going, yeah, possibly salinity is causing the problem. So to Neil, the question I have for you is what's growing in those paddocks?
Well, the 1.31.
Yep.
It's like a mix of, well, that's the Progardes.
Yep.
Plot.
How's the Progardes going?
Not that great.
Yeah.
Yeah. I don't think it really took off the way that Frank thought it would take off.
Yep. And what about
and the rest is just buffle.
Yep. And AA?
Yeah, that's a Mitchell Grass Downs.
Yep.
Paddock with buffle.
So those other paddocks, 9, 10, 11 and 12, they're Mitchell Grass Downs, just Mitchell Grass sort of paddocks or buffle or mixture of grasses?
Yeah, pretty much, yeah.
And how do they perform?
The one that's
pretty good.
Yep.
The one that's X is actually South Dam paddock.
Yep. Okay.
There's a
So
there.
the reason I'm asking you this is because this might be a good example for you, Tennille, of where Progrades is going to get pulled up by the salinity. So like the grasses, like the native grasses there, they've evolved so they're tolerant of that level of salinity. And obviously if there's salt bush around, it's going to look at you and smile when it gets that. But a lot of the introduced species, there's no way they're going to put up with that. So if you saw that down south here, or sort of say Western New South Wales in the western slopes, that kind of level of salinity is bare ground because it's either barley grass or bare ground or salt bush. It's just too saline for most plants. So you're talking that Progrades probably is not the right fit for that paddock. It'll be interesting to see if it thrives or it sort of slowly withers away, because I'm not sure that they've done trials on it and to see its tolerance to high salinity. I know they've done tolerance.
I think we were a trial. I think
okay,
it was a bit of a trial.
Yeah. So the salinity is causing the problem. Now your salinity is not sodium like table salt, which can be in soil, sodium chloride. The salinity that we're talking about is calcium sulfate or gypsum. So your soil is naturally full of gypsum. So it's not like only gypsum, like a gypsum mine, but it is naturally high in the calcium sulfate mineral. And you can see that because we're looking at salinity 1300, and this one 2000 like that. And you can see above it how much available or soluble sulfur you have, really high levels. So that's telling me that it's a sulfur type of salt, and it'll be calcium sulfate. And so that's a classic example for you. So I guess you can sort of see in that example, Tennille, and hopefully everyone else is sort of saying as we go along, that what I've done here is I've measured your salinity, and let's just say it's 2.0, which is 10 times the benchmark, or, if we go with their benchmark. And so their benchmark was 0.2. And apart from the native grasses that are adapted to that soil type, if you put anything introduced in there, it's going to be very unhappy. So it's just not going to thrive. So it's a good example for you of, going, okay, well, I've got to be realistic how far I can improve this soil because it has this unique sort of constraint. So I wouldn't bother with Progrades anymore. Progrades, sorry. In that paddock. But I mean, if they breed a salt tolerant one, then all good. But hopefully everyone else can sort of see how that process we followed. We're kind of just troubleshooting soil health. So I'll keep going along to Abbotsford, I think, is the next one along the park. And I'll come to that second soil test after. It's just that if I jump between soil tests at this time on a Friday night after a long day, you know what's going to happen. I'll be confused and you guys will be confused. So if we come to Abbotsford, we've got L and N was the two we were focusing on. And you can see, Anita and Roger, that the salinity levels in that are within normal range for that area and that soil type. And if we go across to the sandy soil, that's the really sandy 1K, isn't it, Luke? I'm pretty sure. And notice how the salinity in that soil is really, really low.
Yep.
And that's because you don't have the clay minerals in that soil that are holding those sort of salt-based chemicals like gypsum. And they're free draining. They drain a lot more easier over, each year with the rainfall. So any salts or nutrient elements that were in it, because salts are just nutrient elements, that's all they are, has been leached away. So in that soil type, you don't usually have any problems with salinity because it drains so easily.
Okay, yep.
Yeah, and also the sand doesn't have those minerals in it. So the only really big standout really, Tennille, are your soils that have oodles of nutrients in them, but the problem is that they're high salt. They're called gypsic or gypsum-based soil minerals, and it's a unique soil type. I think we had some, Anne, in the last group. We had a few that were in a similar pattern. We did, yeah. And you can see how it is a problem if you're trying to improve country with legumes, because legumes are not nearly as bulletproof as native grasses. And it's the same down here in southeastern Australia. People try and sow, you know, the native grass or the cocksfoot or fescue, or particularly phalaris naturalised grasses. They'll grow in pretty extreme conditions, but not clovers or legumes. They need slightly better balance in the soil. So yeah, probably just don't worry about putting Progrades in those other high salt gypsum type paddocks. Okay, so hopefully that's sort of given you guys a feel for that. I'll just come back to my checklist. And the last thing to quickly look at in the soil health story is sodium percentage. This one here, the next one, sodium percentage. The percentage of sodium, that's what we call exchanging in my soil. So we'll just quickly go over that one. And so the where to find it is about 2/3 of the way down. You'll see this section here. I can make this a bit bigger. Sorry, everyone, it's probably been a bit small. You can see this section here that says it's got the percentages of different elements, calcium, magnesium, potassium, and then it's got this sodium percentage, or also called ESP, which stands for exchangeable sodium percentage. Yeah, it's pretty logical. So what we're looking for is how much sodium is mucking around in our soil on the clay, basically. You can see the numbers. I'm circling them as we go through the soil tests, and I'll give you a benchmark of less than around 6%. So you don't want less than about 6% exchangeable sodium. So some paddocks will tolerate a bit higher, but when you're creeping up to 10%, you do start to get some problems. So this one here, Luke, this soil, this is one of Abbotsford. This soil number N here is, you can see that we've got 10% sodium, and this one at 7.6. Anita, if they're losing organic matter, if those soils are low in organic matter, then that sodium is probably causing problems for the pasture. So it's
definitely the third one. It's pretty well bare ground. The 7.6 is the one that's actually, A to B land condition.
So the key thing is that the organic matter in your soil, or the humus part of organic matter, what we call humus, which I think we touched on earlier in the course, it kind of acts as a kind of chemical buffer or balance. So when you have an imbalanced chemistry like this high sodium that we're seeing, when you have organic matter, it can counter it or mitigate the problem. So the problem with your paddock, that N paddock, is that not only do you have high sodium, but you don't have any organic matter to sort of balance it or counter it. Yep. And that's why you're having a problem. And the problem with these kind of soils are called sodic soils. And the problem with a sodic soil is once you lose the ground cover and the native vegetation off them and the organic matter from them, it's extremely hard to get anything to grow again.
Yeah,
that's the problem with them. Like, not many plants, there's some plants tolerant of salts, but not many are tolerant of sodic soils, especially when they've lost their organic matter and that, you know, that intact ground cover that was there. And that's the problem around Collinsville and those high erosion areas that the barrier reef money's all going to, you guys might have heard of, down sort of towards Bowen. They're sodic soils, and once they've lost the cover, they just erode. They just disappear into the ocean really quickly. So, that's the risk with them. So if I go to everyone's percentage sodium, I'll start from the end there. You can see here, Luke, that your soils have, low levels of sodium, less than 1%. So these are really safe. You don't have any issues. You've got a little bit in that one, but I wouldn't suggest that that's a problem. And you won't see it in the sandy soils because it's only mainly coming from the heavier clay soils have this problem usually. So I don't know why my screen isn't scrolling. There it is. So if I come across, I'm just looking at everyone's soil. So that soil of Anita's, that's definitely an issue. And then as we keep coming over everyone else, you can see that your sodium levels are really low, lower than 5%. Don't worry about it. But yeah, Anita, I'd say that's the issue with that paddock. That's its soil constraint. And if I come right over, okay, so bang. Anne and John, I think I found your problem. So you've got 8.6% sodium in that soil, that the problem paddock, and that's the sodic soil. And if we go up and see what your organic matter is doing, so it's marginal. So and the pH is 9. So I'd suggest to you that it's probable that part of the issue there, if not a lot of the issue, is this high sodium. So it's a sodic soil type. So, and that's the probably the main lever there, or the main influencing factor in those spots, because it can be quite patchy, as you know. These things can be patchy, sodium. So if you go to some of those pivot irrigators doing Rhodes grass, say around Richmond or Charters Towers, they will have sodic patches in the middle of a normal field. So it can be quite patchy, but I reckon that's part of the problem there for sure. Yep.
Righto, great.
No worries. So it's not salinity, it's sodium in the clay, which is that sodicity as the term. So hopefully everyone can see that what we've done in this section, I'll kind of just pull it up because I'm mindful of time, but see how we've just gone through a checklist. I haven't given you the full checklist because if you're in pastoral country like you guys, you're not going to change some of this stuff that you might if you're cropping. So you've just got to live with your pH, and you've got to live with your salinity, and you've got to match your pastures and plants to what you've got. And the only two levers that you can or soil aspects health that you can really improve financially, unless you're Gina Reinhardt with a big checkbook, is these two. And that's all down to grazing management. And the problem for soils when they've lost their ground cover and maybe they've had 150 years and a few droughts and fires and sheep and all the rest of it, especially if they were sensitive soils to start with, like Anita, that paddock with the high sodium was probably a sensitive part of the landscape. And the early settlers didn't really know that, so they kind of treated it the same as everywhere else. But once it lost its ground cover, it never got it back, basically, because of the sodium. And so since then, it's just declined even more. If that makes sense.
Yeah. Am I able to speak to you about them later, David? Because the first one, that's 3.5, was actually where the first ball went in. And so it has been grazed for like 130 years straight pretty well.
Yep.
And yet it's got the 3.5, but the 10 has only had a burrow pit, like a dam near it, in the last sort of 8 years. And it's just gone to shit in that time.
Yeah. It's much more susceptible to change because of the high sodium. The sodium's always been there. And it's a much more risky soil type once it is disturbed. So they reach a threshold, and you can have high sodium, but if you've got high organic matter and perennial grasses, it will stay stable. But once it reaches this threshold of condition loss and ground cover and perenniality loss, they kind of reach this point and then they go. And once they go, they are really hard. I remember doing a job for a bloke in New South Wales, and he bought a property that he didn't know the soils. It wasn't from that area, and it was a third of it was sodic soil. And 25, I met him after 20 years. He was on the place, and he said, it's nearly bankrupted me, this place, because third of the property never grew grass, and he didn't know why until he found out it was sodic soil. So it's very hard to rehabilitate. He was doing rotational grazing and you name it, putting gypsum out, which is expensive if you're in beef cattle. But yeah, so that's the thing. It's reached the threshold. Once it's gone, very hard to save it. It's really hard. And that's why they're having trouble with that country around Charleville, down near Bowen there, in that high risk erosion, sort of the triple B catchments, they're calling them. Yeah. So yeah, it's hard to get ground cover back on them. So, okay, so we've been through a bit of a soil health checklist. So the last thing that we've probably got time for quickly is to look at phosphorus. So let's jump to phosphorus, available phosphorus. So we looked at the total phosphorus, and we saw that some of your soils have really low total and others have, not too bad total phosphorus. But now we want to know how much phosphorus is actually cycling and available in my topsoil, like for my plants. So the way to look for that is this test here, which is this just near the top. This is the Coldwell Phosphorus. If you remember back to the workshop, the last workshop we did, the last seminar, we're looking at Coldwell, which is just an estimate of available phosphorus that's used in Northern Australia. Well, it's used in most of Australia, but not everywhere. And we just want to know our available phosphorus numbers, and here they are here. So if we look across the paddocks, you can see here, Luke, that you have 10. So the benchmark I'm giving you for grazing country in Northern Australia is 8 to 10. So if you're over 8, and better still if you're over 10, you've got, you know, the research has sort of shown that, except for maybe wet season where you've got all that growth and the animals are chasing minerals, but you've got enough available phosphorus cycling if it's around 8 or above. So think of that 8 or above, and then just have a look at your results. So obviously, Luke, that one there is all good. And the key one for me, Luke, is your 4th soil along, less than 1. So that is definitely a low phosphorus paddock. And that those animals will be needing phosphorus supplementation in that paddock. I would be surprised if they're not chasing phosphorus. So it'd be interesting to hear what your observations are on that paddock. And these two here are also low in phosphorus.
Yep. Yeah, haven't never fed phosphorus there, but we'll put some. I've got some here I could put out and see what happens.
Yeah,
so they should be tasting it right now.
Well, it's a low phosphorus paddock. So I guess the next question I have for you is, what's the browse they have in that paddock? Do they get a good mix of browse, and have they got pretty good quality grasses in front of them a lot of the time?
That's all. It's a monoculture of Flinders grass in that.
Okay.
No, it's not. It's probably 30% Mitchell, 70% Flinders grass.
Yeah.
No browse.
Okay. Yeah. Right. So, yeah, it'd be interesting to see if they respond to phosphorus. So, you know, and again, because yeah, at that really low level, there's probably not a lot of phosphorus there is phosphorus in the vegetation, but the landscape will be chasing it. And what you see, you know, you get that bone chewing behavior, which obviously you haven't observed there, or you would have made a mention of it. But that's the kind of country where I'd suggest you're probably going to get a response to some phosphorus supplementation. But yeah, worth doing an experiment, because as you know, the cows and the animal and the grass always throws a curly at you. Yep.
Oh, sorry, I was reading the wrong one. Yeah, you're right. Yeah, I thought you're on the black soil. You're on the forest.
Oh,
no
yeah.
problem.
No,
yeah,
this
sorry,
one.
no Mitchell grass, no Flinders grass there.
Yeah, righto. Yep. This one looks like quite limiting in phosphorus. These ones, I'd say they're marginal, and the problem with marginal is it economic to supplement? And then that's when you look at the cattle and you look at and you go, how do they perform? You know, use the animal performance to guide you a little bit, and then you can supplement. So Tennille, sorry to answer your question. It's right near the bottom, so keep going down. We don't have time to kind of go through everything, but if you go down to number 6. And you can put your totals here and then put your available phosphorus here. So your total you can't benchmark. It's just I've got high or moderate or low levels. But this one you can benchmark against 8 for grazing pastoral country, grazing landscapes in your area. So for your available, put an 8 in that one and then just sort of evaluate against that, if that makes sense. So sorry everyone, I'll come back to that. So if we keep going across to everyone's soils, the other ones are all looking good. So Abbotsford's looking good, and then we've got a couple there that we're not using, and then we're going into Redcliffe, and I would be surprised. So Redcliffe, you've got 11, 9.9. So yeah, you seem to have enough phosphorus, Tennille, in those paddocks. Phosphorus doesn't seem to be a limiting factor. And if we keep going across to the other two, yeah, they all seem to have reasonable levels of phosphorus. So apart from that really low phosphorus over here in the beginning, they've all like tracking their phosphorus pretty well. And the challenge with phosphorus, as you guys know, is sometimes you think it's getting an economic result and sometimes you think you're wasting your money. And the problem is that animals, they graze in landscapes, and if they have mixed browse and if they can move on different soil types, if the same paddock has different soil types, well, they will move through that landscape and their body and their rumen will give them feedback, and they'll they'll get a mixed browse to help themselves. So that's why it's a little bit problematic sometimes. But yeah, really, really low phosphorus like that, Luke, it's probable that supplementation at key times a year is going to be worthwhile. Yeah, so that's phosphorus. We could do the same with sulfur, and if I'll just quickly do that as the last thing, maybe, because I know I've reached time now and it's getting...
Is there any chance that we can have a bit of a quick squiz at Rowan's, which is that separate test?
Yep, let me do that right now. Yep, I'll get that up. Hang on a minute. So Rowan, this is your test here. And so, yeah, sorry, Rowan, it was just too hard to switch between them before. So Rowan, this is a cropped paddock? Am I right in saying that?
He's got his mute on.
Yeah, that's all good. You can give us a thumbs up, Rowan, if that's all good. But I'm just assuming that it's a sorghum crop that you're trying to grow in there based on that. Okay, so if we have a quick look at this test, the first thing I've got to say about it is it won't have totals because these guys never measure totals. And so now I'm just going to look at some of the key soil health things, and I'm going to start with organic matter. And the organic matter, so they reckon it should be at 3, Rowan. So they're saying you're slightly low, and they're giving you the pink, and they're saying you're slightly low. Ideal 3 to 8. Well, 8 in your part of the world is just unrealistic. So this is just a general range that they're saying here. But yeah, if you can get to 3 for a cropping paddock, you'll be doing well. And I think if you're doing 2 to 3, you're okay. So yeah, the organic matter is not too bad. They won't have the carbon to nitrogen ratio on this test because this lab will not have done it, just knowing this kind of agronomy tests. So we can't measure the C to N ratio, but we can then look at the pH. So we're looking at the pH in calcium chloride and water. And yeah, they're saying it's high and they reckon you should be between around 5. Well, that's not going to happen in that part of the world. So they're just wasting their time putting it on there. Thanks, Anita. No worries. Thanks for coming along.
Bye, Anita.
So yeah, Rowan, I wouldn't worry too much about their guideline. They're saying up to 8, which is fair. I think is a more fair range for you. Yes, I'm pretty sure sorghum is fairly tolerant of high pH. So yeah, if it's getting over 9, I don't know to search on sorghum over 9, but certainly 8 to 8.5, the sorghum should be okay. How's it growing? Is it growing all right?
Haven't done it for a while. It was the only soil test that I had. Yep. That's why I just put it in. Yeah.
No worries. You have grown sorghum there before?
Oh yeah, it goes very well.
Okay, yeah. So I wouldn't worry about the pH then, because as you know, the pHs there are naturally high. The organic matter, yeah, don't let it go under 2%, and so that means spelling it and putting it under pasture for a couple of years. Rotate it between pasture and crops if you can. So, if you put it into crops for a couple of years, pull it out and put it under pasture for a few years, that's probably the way to maintain it. Otherwise, your organic matter will decline over the time if you're just continually cropping it. And then once you lose your organic matter under that 1.5%, you're going to have problems, with the soil, get tight, the water holding will go down, all those sort of things.
Yep. Thank you.
So yeah, that's all right. So keeping it over 2% is a good target. It's a big charged soil. So if you're adding, well, you're not going to add pH or gypsum, so we don't need to worry in this situation. So I guess that last thing to quickly look at is the phosphorus, and they've used Olsen Phosphorus. So they've used a test called the Olsen Phosphorus for their available phosphorus. You can see here they're calling it Olsen. It is a different test. It's actually not used in Queensland anymore. It hasn't been used in Queensland for quite some time, really. This lab's still using it a bit. And yeah, they're saying you're low. So if you're growing sorghum, then a little bit of phosphorus fertilizer will be useful. And DAP or MAP are probably your choice of fertilizer. So DAP or DAP or MAP would be the fertilizer to use.
Yeah, that's what I use.
Yep, that's usually the standard. And I don't know what their sort of rate they're sort of telling you, but yeah, I err on the side of caution. It depends what your yield targets are a little bit, but if they're saying 150 kilos of DAP or something, I'd be going in at 120 myself. I just think people over-recommend fertilisers. Your nitrogen's a bit low. If you were going to do something a little bit more lower input, then you could put some legumes in that paddock, rotate it with a legume. But again, I don't know if you can get a legume up there that's going to do the job. But if you did have legumes in a rotation with the sorghum, or even a mixed species, if it depends what you're using it for, if you're baling it or whatever, then a mixed species, throwing a legume in with the sorghum is not a bad idea. I've seen some good crops around Mariba where they've done a 4-way and 6-way mix of sorghum, millet, a couple of cowpeas, a couple of things like that, and they got very good results. And it's that diversity that seems to help the soil. So yeah, you could try something like that, which will mean you can get away with a bit less nitrogen. It'll also help you with your soil health too. But yeah, DAP or MAP is probably the thing to use. And yeah, if the agronomist tells you 150, then go 120, and try and rotate it with a pasture, or just every now and again put it back under pasture a bit. Otherwise, you will lose your organic matter and your structure out of the soil. So, you know, that'll lead you to long-term problems with water and tightness of soil, etc.
Yeah, okay.
And the sulphur's a bit low. So, yeah, for high production, was DAP the only thing they were recommending, or did you try some other blend?
Yeah, no, I went through, also did another soil test and went through a crowd in Maroochydore, and they had a completely different spin on things. And I think a lot of it depends on, as you said right at the start, a lot of the stuff depends when you're cropping, depends on who you're getting and which wheelbarrow they're pushing. So
yes, correct. But like, you know, like DAP's a safe bet, and as long as you maintain soil health with rotation, crop rotation, and not too much tillage, you know, it's pretty safe bet for you. But the problem is that when you get on really high, some of the Rhodes grass paddocks, they just absolutely load it up, and they get very problematic issues with the soil. But the sulfur in here, yeah, that's why I asked you your yields, because yeah, it might pay you to put a bit of sulfur in the blend, in any blend. So if you're getting a fertilizer blend made up with DAP, sometimes you can get a sulfur added to it. There's different, Inside Tech make different blends, but you could just get a little bit of sulfur in it as part of that mix. But something based on DAP with a little bit of sulfur might be the way to go.
Right, very good.
Yep.
Thank you.
No worries. No, you're welcome. And as far as salinity goes and sodium, I better just check sodium. Yeah, so see how your sodium's at 6.4%. So it is quite high. So it's verging on sodic soil. So they're saying ideal range is 1 to 2%. So I don't know what crop they're trying to grow there, because it's, 5% and above 6%. So it's kind of marginal, that sodium. So you really need to be careful, because if you lose organic matter, and you know, you do some tillage and you get a few years of bare ground, then that soil could switch to being quite sodic, and in that case you'll have problems growing, you know, your preferred forage crops, because they're not that tolerant of sodium. So just be mindful of that. And sorghum's, it's not too sensitive, but it's not a sodic soil plant. So just be mindful that it does have that potential to become sodic. And the only way you'll stop that ever becoming a problem is keep your organic matter and your ground cover. So if you lose them, you'll have a paddock that won't grow you anything in 10 years' time. And I can tell you that, having seen sodic soils that they try and crop and nothing grows. So, but yeah, it's just a minor risk. But again, good soil management, you should be right.
Question, Rowan, is that paddock, like where that sample's taken, is that similar to where your, the river erosion is, the riparian erosion?
I think so. That says the old cultivation. Yep, that's it. Yeah.
And I wonder if that has any impact on why, well, I
don't know. It's a very interesting thing, actually, yeah.
Like there's severe erosion, David.
Yeah, it's
whole slabs of banks.
Sodic soil. Well, I guess if that's either force of water during flood flow that's just carving into the side of the bank, or sodic soils tend to start channeling and rilling out from the surface, from just a sloping surface. But if it's just heaving off the side, it's probably just channel flow during flood events. But look,
that was channel flow that's done the damage. But
yeah,
it's interesting to note that that's what happens. Yeah. Yeah.
And the other thing you might get, Rowan, is tunneling. So you'll get erosion underground and then it slumps in. So
you've seen that right on the riverbank itself.
Yep. Okay. So sometimes the subsoil is sodic, and so the riverbank the water erodes into the side of the land where the sodium is, because the sodium kind of collapses the soil structure. That's why it's such a problem.
Yeah.
And then that'll lead you to then you get slumping, and then you get a mini gully form, and then the show starts.
Sodium associated with sandy soil?
Not usually. No, it's
underneath the clay. There's a layer of sandy soil.
Okay, yeah, which sounds like it. Yeah,
most of it does the undercutting, and that causes the slumping.
Okay, so it might not be a sodium reason for that particular issue there, but it looks like that the clay soils in that area have sodium in them. So just be mindful of that. So the good news is that clay itself is pretty coherent, and that's the problem with sodic soils. They're clay, but the sodium makes the clay incoherent and collapse. So just be really careful of it. And that's the problem around Collinsville and down from Charters, where the rivers are all just the landscape's just disappearing. And that's because they're sodic clays. And once they start running, you just can't stop them very hard.
So that's as a sub result of, say, overgrazing or?
Well, yeah, I mean, they sometimes get pretty heated at the workshops in that area about it, because apparently Leichhardt, that explorer, and some of the early explorers, there are naturally areas that have always been sodic, and they're always eroding, pre-European times. So there's definitely, areas of Australia that were sodic or saline and bald, scalding areas naturally, just because of the soil chemistry. But there's definitely other areas like the central New South Wales around Gilgandra and sort of Dubbo, if you know that area, that were sodic soils, but they had really good native grasses and open woodlands when they were first opened up. So, there are areas where the sodium is really extreme, but there's other areas that probably since overgrazing with sheep, it was probably all done in the first 30 years. So, and a couple of droughts, Federation drought and a few other things, and away you go. So, yeah. Righto. Hopefully that's helped everyone. So, and I think that's probably everyone's ready to...
David, you were just going to, sorry,
Yes.
Luke again,
Yes.
talk quickly there about sulphur on the
Oh,
test.
yeah, sorry. Yeah.
What was your, just the guideline? What was it?
Yeah,
benchmark for that?
look, there's actually I haven't found, and I talked to a DAF guy 3 months ago about this. I haven't seen any guidelines for sulphur, so I'm looking at that first soil there. So my personal feeling is that, around that 3 and above for your kind of area, so is really kind of the critical thing. So, you've got a sulphur here of less than 1. So for me, that's really low, but there just hasn't been much research done. And the other thing that happens is that animals will move between soil types. So they'll get their sulphur, eating some browse in one area, and then in the afternoon they're going, or the next day they go somewhere else. But yeah, that paddock there at 1. So I reckon if you're 3 sulphur or under, it's just something to definitely keep an eye on, and maybe supplement or trial a supplement in that country and see if the animals respond to it. Because it may be that it's limiting, especially if they're in that country on that soil type for periods of time. Then definitely trial it. But so my gut feeling is 3, because there isn't really any benchmarks for Northern Australia for sulphur. Like in Southern Australia, higher rainfall, pastures and stuff, we say around 7 to 10. So, and for horticulture, I can give you benchmarks, but there's just never been anything done. People don't see it as a limiting factor. But I think there are some soil types like that one there with 1, where it probably is. But again, if animals can move across soil types and browse, then they will, and that'll help them balance it out for themselves.
Super, thanks. Yep.
No worries. Righto.
Okay, I think we're done. Any other questions?
how's that for everyone? It was a shame that we had a bit of a break between the sessions, but hopefully these sessions are giving you a bit of confidence to look at your soil test. And tonight, you know, as we've gone through it, hopefully you can see that there's often one or two soil constraints that are really the reason why growth's being limited. Obviously management's the other thing, grazing management, but from a soil test, you know, sodium in your part of the world, low organic matter is always going to make things problematic because water won't go in the soil and you won't have water. But also, and bare ground, hot surface in summer, all those problems. But the other thing potentially is that high salinity in some situations, like what you've got, Tennille, and then the sodium, which I think is the limiting factor on a couple of those soils. And some of them have low fertility or a weak link nutrient. And yeah, that low phosphorus would be one in one of Luke's paddocks, and the low sulfur in another. But yeah, so that's sort of a way to use a soil test just to identify your weak links.
Great, thanks very much.
You're welcome. No worries, guys. I hope you're enjoying things
very
up there.
much,
And
David.
you're welcome. No,
Thank you, David.
That's all right. I think it's being recorded too, so if you want to go back over it, I think you can put me on the large TV and watch me while you're having tea one night instead of watching the Cowboys lose. You're all good.
That's no, thanks, David. It's been great. And yeah, we have got all of the recordings are being put together, and they'll all be on our YouTube channel. So it is coming. And Anita's gone, but Anita's been waiting on a one that in particular that she missed out. But they will be all there, so we can go. Everyone will be able to access all that information again.
Great. No worries. No, well, thanks very much for having me up there virtually. And yeah, I look forward to getting up there again sometime in real life. It'll be good. Yeah, you're welcome. No worries.
Thank you.
See you, everyone.
See you, Luke. See you, Tennille. See you, Ron.
Yeah, thanks, everyone. And thank you, David. Really appreciate it. And I'm just trying to unmute. I've muted Roger and I can't seem to unmute him.
That's all right.
But thanks everyone Roger. For giving up your time, and really appreciate everything you've done, David.
You're welcome.
Yeah, like dragged to overtime.
Righto, terrific. Thanks for that.
And it's Roger.
Very valuable. Sorry.
Hello.
Thanks.
Hello, Anne. Roger, can you?
Go ahead, Roger.
Can you get me there, Anne? Can you got me there now?
Yeah, gotcha.
Yeah. Hey, is David gone?
No, he's still here too.
The question I was been trying to ask, with that sodic soil, it's a shame everyone's gone. Is one of the options there where you over, like if it's in patches, and do some of that impact grazing on the.
Roger, you just broke up at the key times, so we didn't quite get your sentence. But if you want to email something through, then I can maybe answer it for you. But you broke up exactly when we were trying to listen to you.
Yeah, it was just about the running people. Sometimes you say people run.
No, and we're not getting you. We're not getting you, Roger. I'm getting one word out of 10, unfortunately. But yeah, look, we can follow up on the email or whatever after, or on the phone.
Yeah, if you email something through, Roger, and when David sends the, either David can flick it out to everybody, or he can send it through to me, and I'll flick it through to everybody.
Yeah, he's gone.
Yep.
Right.
Okay. No, thanks, David. Really appreciate it.
No worries. Oh, you're welcome. All right. Well, I'll catch you later, Anne.
We've gone so much over time. But I think like everyone was getting value out of it. So it's
no, that's good. No, it was good.
Really good. Oh, and like, I think, the ones that have really kept coming back time after time have really got a lot out of it. So it's been great.
Yeah. No, terrific.
Okay.
Oh, well, thank you. All right.
Leave you to it.
Okay. Thanks for that. See ya.
Bye.